Please, for your own safety, do not replicate anything you see in this video. We're working with cyanides and azides in the same compound, so this is for research, not personal use. Hello guys, and welcome back to another video. So today, first of all, I got a new mic, so this might sound better, but second of all, we're going to be starting our quest to make cyanogen azide, and this video is going to kind of be my lab notes-ish to show you all my failures, how I did it, and how I finally successfully made cyanogen azide. Now to start off, to make any cyanogen halide or compound, I need to make cyanide, so I just use the sodium plus potassium ferrocyanide method, threw it in a tin can, and just kind of mixed it all up. Then I put it on my propane heater because that's it's perfect for this application. I ended up actually putting it into a little cap food bowl because the can was too small. So essentially, I'm just going to show you all the clips of me mixing it around to show you the color change and what it looks like throughout the entire process. And the process only takes like 15-20 minutes. It does not take that long. Once I take it off the heat, I just put some paper towel over it because it likes to crack and throw pieces everywhere. And flying pieces of cyanide are not my favorite. Okay, so this is what it looks like when it's completely cooled down, and now all we're going to do is dissolve it in around 60 to 70 milliliters of hot water. It has to be around boiling water temperature so that we can dissolve all of the cyanide. But once it's all dissolved, I throw it on the stir plate to, stir everything, break up all the chunks, and then I filter it. And after it's filtered, you get this yellowish solution, and this is the solution that I pour into 200 to 250 milliliters of ethanol, which crashes it all out. And then we get our pure cyanide. So here's our final dry product. I dried it on a hot water bath, which literally just turned the cyanide brown and into super hard chunks, which is not my favorite. The next time I did it, I used a vacuum, and it turned it into this nice fluffy powder. So I highly recommend drying it in a vacuum and not using heat. Although it looks horrible, it still worked perfectly fine for every reaction I needed it for, so it's fine in the end. Okay, so now that you know how I made my cyanide, it's time to make my first cyanogen halide, or at least the first attempt, which is cyanogen bromide. Now what you see right there is bromine that I weighed out, because obviously you need bromine for this reaction. The bromine was very easy to make. I just used the single replacement reaction with sodium bromide and chlorine gas. So yeah, I just distilled it off, high yielding from there. So I got plenty of bromine. However, the cyanide is a little hard because I do have to do that synthesis over and over again, because it only gives me like 15 grams, which I end up doing a lot of failures, so I need a lot more than, I use around I'm probably on my 70 gram mark right now. I've used so much. But yeah, so for my first attempt, I set it up in a nice bath. I had on strong enough stirring so that it wouldn't splash. I had a fan to blow away all the bad fumes, and that seemed to be a pretty good setup overall. However, the only problem is that, now looking back on this, I ended up not adding enough cyanide. However, I'll get to that later, but all you need to know right now is that this one it wasn't a complete failure, but it was a pretty big failure because the bromine contamination kind of screwed up everything. I did put in a thermometer to make sure I wasn't going, too far above 0 degrees Celsius, but it ended up not really mattering because I don't really have that much, and I can't really measure the temperature accurately. When I finished my additions, I had this really dark red mixture, almost brown, but you could definitely tell that it's red. And here lies the problem. I was actually supposed to go further with adding the cyanide, because there's a lot of excess bromine, and that's going to come over in our distillation. So as you see the 75-degree elbow joint that I'm demonstrating how I'm going to use, I'm just going to put it into the little flask, and I'm going to angle it with my clamp into the ice bath with the beaker so that it's facing all the way at the bottom, so that when it sublimes, or I guess boils at this point, it's going to condense at the bottom of the beaker and I can collect it from there. One more thing I forgot to mention is that besides the bromine contamination, there's a lot of water contamination, which is another problem with this first attempt. However, if you look really closely, you can actually see crystals forming, which means that I actually successfully did it. Sadly, I didn't recover a single crystal, and every single one was lost, because I didn't cover the top of the beakers, so they all just sublimed away. So yeah, this first run was kind of just to, I guess, prove to me that I could make it. However, in later runs, I fixed all of these problems, but this first time that I did it, I thought that it was just the synthesis that was bad, and not me, so I decided to make another cyanogen halide. However, before I moved on to the next cyanogen halide, I did try cyanogen bromide one more time, except I used the long tube condenser, and I ended up actually breaking my long tube condenser, which I repurposed for a later experiment that you'll see. And, yeah, that kind of made me sad, and it ended up working even worse than the one before, and again, I did lose all my cyanogen bromide crystals to sublimation again, even though I covered the top, because I tried to recover them and they just all disappeared. So that is when I gave up on cyanogen bromide and moved to cyanogen iodide. So the cyanogen iodide is literally the exact same setup, except you use iodine, and you're supposed to drip the iodine, or not really drip, but pour the iodine slowly into the cyanide. This ends up being such a messy process and literally makes me want to blow my brains out. I had to make my own diethyl ether because I didn't have any that I could distill or had any to begin with, so I had to make it, and oh, it was so messy. It took me forever. And on top of that, I wasted all of it trying to recover this stupid cyanogen iodide that did not want to even work at all. So at this point I was just praying that it would work and that I could at least recover something, but of course it just ends up being this oily stuff that sticks to all my glassware, ruins it, stains everything with iodine, smells horrible, evaporates super quickly, which means that smell goes everywhere. It's literally the worst stuff I think I've ever worked with. So that is when I quickly said, no, I hate you, cyanogen iodide. So I apologized to the bromine. I said, sorry, bromine. I hate iodine. I'm coming back to you. I love you. Please, please work for me. And it actually ended up working this time. I actually ended up successfully distilling it over. Now it did have, I still didn't go far enough with the cyanide additions because it still had bromine contamination, but I actually got yield from it. I actually was able to recover stuff. Now the reason why this reaction actually worked and I actually got good yield from it was because I did it anhydrous. I didn't use any water in the beginning and I used as little as I could afterward. But turns out that's not the case. You actually do need water to get a higher yield. But I mean, doing it anhydrous still works, just not as well. It's just the reason it wasn't working before with the water with the cyanogen bromide was because I was just really bad at doing it. So at this point I was getting scared and worried because I was running out of options. My cyanogen iodide wasn't even close to working. I did not want to try that again. My cyanogen bromide wasn't working because it just, like, I got it, but it was really impure. It had a lot of bromine contamination, and I don't want to recrystallize it because I have such a small amount. I'll just lose a bunch and have, again, zero yield. So I decided to make cyanogen chloride, by far the most dangerous and scary one. So, yeah. So here is the most cursed chemistry setup I think you will ever see for making cyanogen chloride, and it actually ends up working. I do get cyanogen chloride, however I only get around a gram, which is super low yield because I used around like 13 grams of the cyanide. So the process is really tedious because you essentially saturate your 100 milliliters of water, which is what I was using, with chlorine, and then drip in the cyanide until the chlorine color goes away and turns to more of this brownish color that you see. And then you resaturate and redrip and resaturate and redrip over and over again until you're out of the cyanide. And it's better to have excess chlorine. So now I set up for a simple distillation, which I have salt ice water for my ice bath for the receiver, and for the condenser water because this stuff's got to be really, really cold in order to get it to even come over. But obviously it didn't even work that well. Okay, so I go back to the bromide again because I don't like the chloride, it's too hard to work with. I don't like the iodide because it turns up that iodide actually does not work for the cyanogen-azide reaction in the end. So that would have been bad if I, got it anyways. But the cyanogen bromide, I figured out that there is you're easily able to tell the endpoint, and it's when it turns to this really brownish color, and it happens almost instantly, so that's when you know that your reaction's done. I also put calcium chloride to dry the product as I'm distilling it over. Since I actually drove the reaction to, finishing up, and I actually liberated all the bromine and dried the product, I got these beautiful, perfectly white and dry, just crystals of the cyanogen bromide. Funny story, I actually had a different ending to this video where I proposed my own reaction in order to get the cyanogen-azide to work, but what do you know, 3 days later, it doesn't work. It's just a nasty red solution that smells like cyanogen bromide and is a waste of all my supplies. However, there is a silver lining. After weeks and weeks of searching online, I found one article, one single article to rise above them all, and it gave me a synthesis to make cyanogen azide from cyanogen bromide, and it worked. Funnily enough, all I had to do to make it work was do the exact opposite of how I was doing it before. This time, instead of adding the cyanogen bromide to the stirred suspension of sodium azide, I had to add the sodium azide to the dissolved solution of cyanogen bromide. The procedure that I was following calls for 50 milliliters of dry acetonitrile, and I'm going to dissolve 10 millimoles of cyanogen bromide into the acetonitrile. Now, this reaction is going to be done at 0 degrees Celsius, so I'm going to have to throw this in an ice bath. So, once that's all dissolved, you slowly add your 40 millimoles of sodium azide. So instead of doing a 1 to 1 molar ratio, you're doing a 1 to 4. So you're adding a lot of excess sodium azide, which is, in my opinion, what the problem was with everything else. I think you need a lot of excess sodium azide so that you can actually get it to have a good reaction time. And it worked. All you had to do was react it for 4 to 6 hours. I ended up reacting it for 6 hours, but it actually ended up working.
Oh, that's perfect.
Thank you everybody so much for watching. This video took over a month to put together because of all my failed experiments. So, I hope you enjoy, because this took a lot of time.